This video lecture supplements a workbook for Beck's Introduction to SQL Programming, the Pelican Companion. The corresponding textbook is Beck's Introduction to SQL Programming, that Pelican database book. The workbook and printed copy of the companion textbook may be purchased from lulu.com. You may download the textbook for free in ebook format from beckplanet.com/books. Important note on SQL Server and MySQL. The material presented supports both the SQL Server and MySQL environments. Where differences in SQL dialect and environment arise, solutions for both environments will be demonstrated. Where the SQL code is common across environments, only one environment is used for demonstration, as the code runs identically in the other environment. Chapter 5, Parallel Exercises, Solution Walkthrough with Commentary. Pro tip. Before we get started on this parallel exercise set, here is a pro tip you may find useful. Many SQL clients have a feature which will automatically script a template for common tasks such as creating, updating, or deleting a record on a table. Both the MySQL Workbench client and the SQL Server Management Studio client have this feature. In the following video, I will demonstrate using this feature in the Heidi SQL Query client. I'm going to leave you with the challenge of researching and discovering how to use this feature in Workbench or SSMS. It can be a real time saver. So here's the demonstration of a feature that I think you'll find to be a real time saver in your learning and in your code development, even into your professional work when you've mastered this craft. And that is the Heidi SQL client, similar to many other SQL clients, such as the MySQL Workbench SQL client and the Microsoft SQL Server Management Studio, has a feature that will allow you to create a template ad hoc for inserts, updates, and deletes on any arbitrary table. So for instance, let's say we wanted to work with the Salon database and we want to craft an insert on the customer table. In the Heidi SQL query client, this is implemented over here in the columns. I can come and select the columns that I want included in the insert. I'll select all of them. And if I right click, I can then select the query type that I'm interested in creating. In this case, it's an insert query. And I get an empty template ready for me to provide the appropriate values that I want to insert for each of the fields I've selected. And then I'm ready to run my code. This can be very useful in learning how to craft your insert statements or your select statements or your delete statements, but it's also an excellent time saver for professionals as you're building your code and just want to cut to the chase and not do a lot of typing and fix a lot of typing errors. It's a great way to get a head start. So investigate that for your MySQL environment and for your SQL Server environment as may be the case, and I hope you enjoy it. Preparation. Make certain you have connected to your DBMS, SQL Server or MySQL, using your query client, e.g. SSMS or MySQL Workbench. If the Candy database already exists, it's a good idea to start by dropping and recreating it so that everything is in the expected startup state. Run the Candy database creation script appropriate to your DBMS, SQL Server or MySQL. Review the script execution results to ensure that the database and its data were successfully created. Additional preparation. In preparation for the following exercise, please do the following. 1. Create a Big 3 table on the Candy database by executing the provided query. 2. Create a Valley client table on the Candy database by executing the provided query. Parallel exercise 1. Use the Candy database. Insert into the Big 3 table the product number, description, manufacturer number, warehouse, quantity on hand, and price from the product table for only those candies whose manufacturer is in the list 7, 10, or 12. At the heart of parallel exercise 1, we're asked to do an insert using an existing table as a source. So the simple way to address this is to start with the select of the rows from the table that is the source and the fields that you want to include and build just the select query. And once we have the select query generating what we'd like to insert, we can simply take that select expression and wrap that up into an insert into and enumerate our fields. And then run the combined query that has the insert into and the select. And then we can check our results by doing a select star from the destination table. Of course, it helps to spell the destination table correctly. Try that again. And there we have it.
Parallel exercise 2. Use the candy database. Write and execute a single query on the Big 3 table to decrease the price of each candy made by Nestle's by 6.2%. Tip: price is data type decimal 92. If your calculation uses higher precision, more decimal places, you may get a warning, which you could safely ignore, as we only need to preserve precision to the nearest penny. However, a really pro DBA would use the cast function to make the conversion to the lesser precision explicit, which avoids the generation of a warning message. For example, if we wanted to store the results of the calculation price times 0.855 back into the price field, we would use this code. Price equals cast the quantity price times 0.855 as decimal 92 in parentheses.
In exercise 5.2, we're going to do a fairly straightforward update. We're updating the Big 3 table, and our filter is going to be where manufacturer number is 12. And then we can use the expression to set the price field equal to the result of the calculation price times 0.938. And that's fine, that works, but you may see that you generate a warning. And the problem here is that we can cross precision. And so, although this will work and you can safely ignore the warning if your system generates it, a really pro move would be to be specific about how we want the precision handled by adding a cast. And so this is what I recommend. And we'll set the price equal to a cast of that expression to a decimal 92, which matches the destination field data type. And that will work without generating any warning, and there's no ambiguity about did we lose or ignore some precision that we wanted otherwise to preserve. Let's give that a try. Okay. And then let's check and make sure that that ran correctly. And that looks good.
Parallel exercise 3. Use the Candy database. Write and execute a single query to add the following record to the Big 3 table. Product number 299. Description: Hershey's Milkalicious, manufacturer number 7, quantity on hand 500, warehouse 2, price 57 cents.
Parallel exercise 3 is a straightforward insert. So we're going to insert into the Big 3 table these values and execute it and see that it inserted correctly. And we can check that empirically by selecting the updated row back out. And that's what we expect.
Parallel exercise 4. Use the Candy database. Write and execute a single query to delete every record in the Big 3 table which has the string MILK anywhere in the description.
Parallel exercise 4 requires us to delete one or more records, and the time-honored way of doing a delete is to cautiously start by first doing a select, inspecting what the select generates, and confirming that that is what you intend to be deleting. Then just change the select statement to a delete statement. Let's see how that goes. So here's a simple select of the Big 3 table where the description is like a particular string. And we check that, and yes, those are the records we would like to delete. So we can take that and change it from a select to a delete, and we would expect to see 6 records deleted. And indeed, there were 6 records deleted. And of course, empirically, we can double check that the delete went as intended by running the select again and seeing that there are no records returned because those records that had matched the select criteria have been deleted.
Parallel exercise 5. Use the Candy database. In the Big 3 table, change the price for the candy with product number of 162 to 47 cents.
Parallel exercise 5.5 is a very simple update. So we're going to update the Big 3 table, and we're going to set the price to 47 cents, where the product num is 162. Let's run it. We had one row affected, which is what we'd expect. And let's inspect empirically the result just to satisfy ourselves that it updated as intended. And there we are, 47 cents.
Parallel exercise 6. Use the Candy database. Write and execute a single query which inserts into the Valley client table the client number, client name, street, city, postal code, balance, credit limit, and sales agent number from the customer's records for customers in North Hollywood, Tarzana, or Van Nuys.
Attentive viewers will notice that parallel exercise 6 is a problem type we've seen before, and that is we're going to do an insert into a table using another table as the source. And so we can use the same technique we've learned previously, which is to start with the select of the fields from the source table and records from the source table that we want. So we craft the select query to generate the desired data to be migrated, run it, and confirm that the select generates the intended result. And once that has been generated, all we need to do is expand that to be contained in the desired insert, put it into our destination table, and run that. And we had 6 rows that we had selected, and now we have 6 rows that have been inserted. And of course, we can inspect this empirically and see that the data that we wanted to migrate from one table to another has indeed been successfully migrated.
Parallel exercise 7. Use the Candy database. Insert the following record into Valley Client. Client number 999, client name Barney's Tropical Treats, street 13816 Sherman Way, city Van Nuys, state California, postal code 91405, balance null, credit limit $1,000, and sales agent number 4.
In parallel exercise 7, we're inserting a single row. And so let's start with the insert statement and the enumeration of each of the fields that will receive data. And then let's provide the values to be inserted into those fields and execute it. And we see that one row has been created. And then let's generate a select to test empirically our result. And that is as expected.
Parallel exercise 8. Use the Candy database. Change the city name for all Valley clients in Tarzana who have a street address on Dwight Avenue to North Hills.
In exercise 8, we are updating the Valley client, and we want to do that where 2 criteria are true. One is where the city is Tarzana, and the second criteria is that the street contains the string anywhere in it, Dwight Avenue. And what we're looking to change about the selected records is that the city will become North Hills. All right, let's run that. And then craft a select to see that if the city is Tarzana and the street contains Dwight Avenue, the city becomes North Hills. And indeed, the city is North Hills.
Parallel exercise 9. Use the Candy database. Delete the client in the Valley client table with customer ID value 999.
In parallel exercise 9, we want to delete the record that has a customer ID value of 999. And as we have learned previously, it's prudent to begin with a select statement. Make sure that it is selecting and targeting only the desired record or records. And we're happy with that. And once that is the case, we can simply convert that from a select to a delete. And so we're deleting one record. We would expect to see one record deleted. And there was one row that was affected. And again, We can test this empirically, change that back to a select, run it, and we find that there are no results. And that makes sense because the previous result of one row has been deleted just as intended.
Parallel exercise 10. Use the Candy database. Client number 126 will no longer be served by sales agent number 2, but the new sales agent has not been assigned yet. Change the Valley Client table to reflect this.
Parallel exercise 10 demonstrates to us that although we more commonly will take and update a value that is null to a specific value, there are occasions when we need to take and remove a known value and it becomes an unknown or null value. And that can happen. You can go from null to a known value or from a known value back to an ambiguous or unknown state. That certainly can happen. And so let's see that here. So we're updating Valley Client. We're going to set the sales agent num to null because we have some Valley Client records where the sales agent, which was previously one given sales agent, is now unknown. We're in an interim state where maybe we've had an employee quit or have dismissed an employee, and we have not yet assigned their clients to a new sales agent. So we're going to, at least for the time being, set the value to sales agent num being null. Okay, let's execute that. And it looks like one row was affected. And of course, let's take a look at that empirically with the select statement, and we check and see, and indeed, the sales agent num for client number 126 is now null.
Thank you for watching. Please visit beckplanet.com/books for additional free student and instructor learning resources, a free ebook copy of Beck's Introduction to SQL Programming, that Pelican database book, and to learn more about print editions of the textbook and workbook.